we're also working with some international folks to help with um, to help launch those groups. So we do look at it as a global effort, and really the mission is to get folks interested in healthcare. Although we are starting to really narrow that mission a little bit further and looking at specific issues inside the industry. Like for example, one of the things I've learned recently is there's a shortcoming of informaticists. And so I think that that could be a niche that we could look at, right? Like how can we help inspire young people to get into the informaticist field? And so one of the ways we do that, our group, is we have a Discord server that we invest in. And the reason why we choose Discord for one of our primary platforms is because it does have reach to hundreds of millions of younger folks. And so that aligns with our mission of getting younger folks into meetings. And so how do we do that? We just get together and we talk about really cool technology, and that's it. And people are either, that's it, and people are either interested in it or they're not, right? Like we're not trying to recruit people. We're not the army or anything. We're not trying to sell anything, but it's really just trying to get world-class speakers like Brian and quality folks to show up at meetings like this or the one-day events that we do. So that's a little bit about us and our mission. Hopefully my audio problem straightened up. And if not, we'll just cut that part out of the video. That's what good editors are for. And so with that said, Brian, I'll switch it over to you. So first I'll go ahead and turn myself off, and then you onto the screen. There you go.
Oh, did you unmute yourself?
No.
Because I'm unmute.
It's mute.
Hello?
Okay.
Also, do you want to just turn off your audio?
Yeah.
Hello. Yeah, so this is put together to be very much like a conversational rather than like me standing up and presenting to y'all. So if anyone has any questions like partway through, you're more than welcome to pitch it. Same thing, Paul, if anyone online has any questions partway through, you're more than welcome to jump in. Also, if you have any comments or interesting sort of tidbits from your personal experience, that's also very much welcome. So as a form of introduction, my name is Brian Autumn. I work as a software concept accelerator for a large fintech out of Boston. And I'm also on the side, I have my own software consultancy, Software Solutions LLC, where I help people out with navigating like newer kinds of software. And I run Boston Code and Coffee, which is the largest software engineering community in Boston. So I stay busy. So the title of the talk has changed very slightly. So originally this was supposed to be AutoGPT and autonomous agents, but then 2 weeks ago, Microsoft dropped AutoGen, which completely changed the landscape of autonomous agents. So in the spirit of quick iteration, we've now switched the title over to the next and greatest. So I spent the last couple of weeks looking over, spent the last couple of weeks looking over the AutoGen paper, as well as a couple of other papers that I took reference to try to have an understanding of like where autonomous agents are. Large part of this conversation is talking about like where this technology is, especially in relation to everything else that's coming out, because there's so much happening in the AI space. It's super confusing to tell what is where. So starting from the very beginning, is autonomous agents. So what is autonomous agent? An autonomous agent is some sort of LLM system that makes decisions, takes action with those decisions, and then it has minimal human effort. So these are like the three parts of what sort of like sets autonomous agents apart from like ChatGPT plugins or LangChain or just like BART, Lambda, Llama, and other sort of like foundational models, is that we want autonomous agents to be able to make its own decisions. We want it so these agents have the ability to act on those decisions, and we want it so humans have very little involvement in this process. So it's very autonomous, very self-sufficient. But one of the biggest limitations is that LLMs fundamentally do not have the ability to think. Like, they literally don't think. Because how LLMs work at a very simple level is that they work off of linguistic relationships. So all foundational models are created by feeding it like the entire internet's worth of human conversations, chat, text, and then the model understands how every word, every phrase, every sentence, every punctuation relates to everything else. And then the main job of a foundational model is to guess what the next sequence of characters is, given the preceding sequence of characters, based off of all of this linguistic understanding. I think that's perfect. Linguistic understanding. So essentially, you feed it like a sentence, and it will predict what the most likely next sentence is, which also creates the amusing but difficult challenge of, by definition, it is the least creative thing, because we fed it all of human understanding, and we're asking for the most likely answer, which is by definition the least creative thing. But when it comes to autonomous agents, they can't think. They can't logically deduce. All the behavior you see out of an LLM, and this is like ChatGPT, you go on there and ask it to solve problems, is all emergent behavior because of how powerful human linguistics is. So like saying LLMs can't think isn't to say that LLMs aren't capable of doing like thought-like processes, but that's emergent behavior. It's not part of what its core value is. And this is why if you ask it to do math problems, it just falls on its face. You could ask it like philosophy, it'll spit out philosophy at you, but it doesn't understand math because math requires it to think through a problem. And all it's going to do is see similar math problems, and it's just going to pick the next likely thing, which is going to be some random number. And that's usually where you see a lot of hallucinations, is that if you don't think about it, it makes sense. It's only when you apply your logical mind that the hallucinations stop making sense. So this is one foundational problem when it comes to dealing with agents. But with agents, we have what's like I key as an autonomous spectrum, which is how much work is accomplished between human intervention. So the very least smallest part of this, so smallest amount of autonomy, is you have just simply foundational models. There's a lot of human intervention. So if you go on to like ChatGPT, you go to BAR, you go to whatever Elon Musk is cooking up with X, and you ask it like a question, and it gives you a straight answer, and it's not doing any sort of web request. It's not doing any sort of referencing other databases. It's just doing a straight foundational model thing. This is the least amount of work. When you're going to the LLM, they're coming back. One step below that is we have a series of products that are augmented generation, which is you ask the LLM to do something, but it'll go to the internet to retrieve information. It'll go to an API. It'll go to a database. It might do a couple different steps. But ultimately, what's happening is it's just feeding it into your prompt, which is then sent back to you, and all the LLM is doing is just making it sound pretty. And then autonomous agents are sort of the highest level, where with agents, you want them to go off into the wild, do all sorts of crazy stuff, and then only when it's completed the task does it come back to us. So like very little human intervention. If you can sort of think of this as how many computer cycles you have before a human has to be intervening. So autonomous agents, lots of interaction with foundational models being used. So breaking this down, foundational models, you have your human, you reach out to ChatGPT, you get that. That's all that's doing. If you're talking to ChatGPT and you're just asking it a basic question, this is all that's happening. This is making it sound really simple. There's a bunch of layers and stuff under that, and like the LMs are complex, and there's like safety layers, there's like human relevancy layers, reinforcement layers. But foundationally, when we're talking about like systems, this is sort of like the basic sort of architecture. Yeah.
Just because it's have a great too, but you know what? It's okay. I know it's whatever, but again, because And one more thing is that the drink order got messed up, so there's only 5 sodas, so we'll have to share the sodas. There is water down the hall too, and that's it, Brian.
I feel like this is the best reason to be interrupted. I will never be disappointed when someone interrupts me for food. Dude.
So you're saying that autonomous agents, you're saying that the one level up from autonomous agent, it kind of an API, it's something from predetermined data source and stuff which like data sources to consult, is it kind of just
so there's a subtle difference between the two, which is part of the reason I wanted to break this down into detail, because I find it kind of confusing what the difference is between an autonomous agent versus plugins. Because both of them are making decisions, both of them are accessing APIs. The difference between the two is the amount of decision making we give to the LLM. So, and I'll get into like really detail in a second, is that for like ChatGPT plugins, it's almost like we're putting it on rails, that it can make decisions, but only within a very specific band. Whereas for agents, we give it a lot more breadth of choices that it can make. So that's sort of like the difference, but it's very much like I've made it look like there's 3 different things, but this is like a gray spectrum where things will be like in different places of that spectrum. And I think that's what makes this conversation and just LLM conversations really confusing, is because there's a lot of things that sound like they do the same thing and they're subtly different. And I think it's only now that we're starting to like congeal around the current definitions of understanding. But yeah, so this is the foundation of the model. Yeah, go ahead.
Think about like in health, like oncology, most realistic what folks are today to start setting up be some sort of prediction, right? And so typically what that looks like is you actually feed them all and you get a result, right? You're doing that through an app or something. But for those involved in healthcare workflow, the process of looking at an image and making a decision, then deciding what to do with it from there is it's more than just looking at the image, right? So what was neat is they actually showed there was actually a really great peer-reviewed research paper on this. It was just published in this week where they showed, okay, now the new process is we're still going to have the MLL model. By the way, to Brian's point, there's lots of models, right? And you can talk with different problems with agents and whatnot. But we can do things like use an LLM to create the note back to the doctor, for example. We can go through something like safety check, to make sure that the form that we're about to send is correct, right? But see how there's like a sequence of things that we may want to do behind and separate from the human. So I just thought that was fascinating. The thing that's brand new too. It's just very recently last week, and again, it's this real world use cases of healthcare.
Yeah, I think that's like a perfect example. Because the other thing too is that a lot of times with these agents is you will actually have like LLMs that have very specific roles. And I think that's the other thing that makes this confusing, is that LLM is a very general tool. So oftentimes where an LLM is in the system should be defined less about the technology and more what the technology's goal is. So jumping into like augmented generation is where this differs, is like you'll do a request to the ChatGPT, which will then do a request to your API, which will send it back to a different call to the LLM to send it back to you. So you'll notice here there's 2 different calls to the LLM. They have 2 different roles, technically 3 different, because one call is going to figure out what API you want to call. Then the LLM has to form the query for that API so to be able to invoke the tool. And that'll either be form a REST request or form like a small snippet of code that will then execute it in some other environment, typically Python. And then when you get the response back, you have to invoke the LLM again to compose the response of the API into something that's human readable. So you can sort of see like this is a little bit more sophisticated. But the big thing with like augmented generation, the best way I would describe this is it's there and back again. Is that like you ask it to do something and it's going to do that one task and come right back. Like it's not going to be going off in tangents and whatnot, because it's very sort of like boxed in.
With this don't use tool, but you use different tools. One is query.
Yeah, so depending on how it's set up, and this is sort of like very generalized, is that might be like one LLM request, or you could break it down into two. It depends on like how the system's set
I'm
up.
just wondering whether the first one would in fact be an LLM or some other form.
Well, I think actually I love that statement. It doesn't have to be an LLM.
We're actually using the LLM to create a SQL statement, and it's some really cool growth that we can share from an engineer at Microsoft that's been working on this really for this recently. And so basically what it is like you take a natural language statement, like show me the department that had the highest FTE across the hospital. And what it will do is it will take that human sentence and send it to the LLM with very strict instructions though. Like you're supposed to create a SQL prompt. And by the way, here's the JSON schema of the table. Like that's what's really cool with this. It's kind of you get super specific, right? And then what you do is you give all that, and then you take this resulting SQL query, you look at all your data in your SQL Server database, and now you move down to the second part of my slide, which is okay. Then you take all that and you give it back to the LLM again. And you say, okay, take the answer now, which is all grounded data. In this case, it's grounded by the SQL Server query, right? We both from SQL Server, so we're grounding that data. And so that's the use case slightly different way to your point. So there we're not even going we are technically helping convert the T-SQL query, but then we're going off to a SQL Server afterwards.
Okay, thank you for stalling, Paul, so I could get food.
It's not sharing talking, right? So you can eat. So you can
Oh, it's wonderful. Perfect. So this is like augmented generation, and this is like ChatGPT plugins is one example of this. Another one is like RAG, where you'll go to like a vector database. So what'll happen is that the LLM will actually put together a query against a vector database, and it'll return like the top 10 most relevant documents. So the compose step, the LLM not just composing, but it'll also filter out what it thinks is relevant. So there's a bunch of really cool like examples of this, and this also only shows one, but you could actually access multiple APIs, maybe even calling other LLMs to fetch other kinds of data. So like this is a very sort of like composable, but the big thing here though is that you're going out and then you're coming back. And then we have agents. The big thing about agents is you are more or less having ChatGPT query itself. So like a very common, some examples of this is chain of thought or sort of like React. So chain of thought is essentially you keep on asking, you have the LLM sort of like pose questions like what is the next thing you have to think about? Given this, what's the next thing you have to think about? What's the next thing you have to think about? You keep on having it break down the problem again and again. Actually, not unlike how people think. Then there's another one called React, which is about like think, act. So that vaguely works along the line of you give the LLM a problem, and the framework will prompt the LLM, okay, what's the first step you need to do? Can you break this into steps? And then for each step, it will actually redelegate it to itself and be like, break this down. What's the action? Until it goes down to a point where the LLM is like, I can take a decisive action. And then it will invoke APIs and whatnot and then come back. So the big thing is the idea that like now you have the LLM thinking about what to do. When it decides it can make an action, it'll go take that action, whether that's doing API call, referencing a database. And only when the LLM decides I'm good now, does it return back to the user what's happening. And there's a couple other ways to like agents can be set up. So this is sort of a single agent setup. But you can also there's a debate pattern where you'll have essentially two different LLMs, two separate contexts, where you essentially have them debate each other on what the next action should be. So it's multi-agent debate, and this is proven to be a little bit more effective than just having it ask itself to break down like what's the best next step. And then so you can get all the way to like a crazy multi-agent setup where you'll have different contexts. Like you might have one LLM act as the role of a code writer. Another one might be like a code reviewer that's reviewing the code writer's code. And then you have like an orchestrator. And so you can have all this network of agents doing different kinds of tasks. all calling APIs and doing stuff and going back to the user. But again, like the fundamental difficulty we have with it is because the LLMs can't think, it will hallucinate. And LLMs generally can be thought of as being like an 80% effective solution on any given task. When you keep on asking it on a task when it only has 80% solution, it will sometimes the errors will multiply and stack on each other. And so a lot of the previous attempts have been interesting on an academic pursuit, but haven't been very useful. So like the useful use of agents is still somewhat of a very, very new kind of phenomenon. Now, like we got ChatGPT like plugins, like 6 months ago, something like that, 7 months ago. And AutoGen got released 2 weeks ago. And this is like Microsoft's foray into this after seeing sort of like the bodies thrown around the battlefield of all the previous agent attempts and being like, okay, we think we can actually start to put something that's actually practical. But going into like the agent systems, there's 2 main agent systems. We have like lane chain agents, transform agents, AutoGPT. These are single agent. So single agent, it keeps on asking itself questions and it keeps on narrowing itself down. And we've had like Baby AGI, Camel Meta GPT. These are the big ones. So like the multi-agent space, and they have different roles. Where AutoGen is a bit different than previous attempts is that AutoGen is something of like a meta framework. So whereas like AutoGPT and LangChain agents are designed for single agent use, and Baby AGI and like Meta GPT are meant for multi-agent use, AutoGen you can do both multi and single agent use, and AutoGen is a lot more focused on like the connective tissue around how the LLM communicates with other potential LLM and users, and not so focused on one particular way of arrangement, which is where a lot of these other ones sit down. And the other ones, like, we think this arrangement is the best, where AutoGen's like, you can come in and arrange it however you like. So it's about giving you that kind of flexibility of arranging it, but it simplifies the communication aspect of it. Cool. And then we have these. And these are the 6 main use cases. So like the hello world for AutoGen. So these are like all part of the actual paper. If you actually find this interesting, I would recommend reading the paper because it's not that hard to read, it's not that long to read, but it's really fascinating dive into sort of like the current mind thought of agents. And there's 2 particular ones I think are really interesting in terms of discussion. There's one where they create a system for solving math problems like a tutor, and another one that got a lot of publicity, which is chess. So with the chess use case, how this works for the agent setup is that you have either a human or an AI. And the idea with agents with AutoGen is that an agent can be either an LLM or human. So you can create situations where it's interchangeable. So for the chess setup is that you can have an AI versus an AI, a human versus a human, or you could have like a human versus an AI, and the fundamental architecture works the same. So you have one player, another player, they're talking between each other. Now, the challenge with just having this setup is because humans lie, AIs hallucinate. So you create essentially a referee, ChatGPT, that's backed by code that can determine the valid board state. So it'll make sure like the actual board state's correct, that the moves are legitimate. And this is what's called grounding, which is super important in agent use cases. Is with grounding, you want to make sure that the agent has some sort of like definitive reference saying like this is correct. So whether that's a human saying this is correct, or you have some sort of other system saying this is correct, and you need some sort of grounding. And this helps prevent hallucination like chains from like sending the agent in some sort of random crazy thing. If you've ever tried to play, and I have done this by the way, you try to play chess with this ChatGPT with nothing else, you'll start forgetting what the board looks like. Also just start giving you the random moves that makes no sense. But again, it can't think. And so this is a really good example of LLM can't think. So even in the paper, they acknowledge that like when they were playing the conversational chess with the LLM just kept on doing crazy random moves that made no sense because it doesn't understand how chess works. So largely how conversational chess is, it just keeps on talking to the LLM until it happens to spit out something that's valid. So I guess it's technically slightly better than random guessing for chess moves, but it doesn't really say how good of a chess player it is. I suspect it's probably not a very good chess player. And I've been actually very interested to see. I haven't seen any discussion how good it is.
Yeah, I don't know. I think it was more just to illustrate the back and forth, and like I don't know though. I don't know. Maybe there's a way to change it. I haven't looked at this example.
Yeah, I haven't looked at this example, but I think the thing I think this is really interesting to me. People are talking about like this being like the new AGI, artificial general intelligence. Our jobs are going to be lost. The world's going to come to an end because we have new AI overlords. Yet we can barely get to play chess. Like it's very humbling to see like, okay, this is sort of like where we're trying to figure out. And we might be able to like loop in a call to like a chess AI. But now all of a sudden, it's no longer just one general intelligence. We have to build a system of AI to solve tasks. This is where I think, like in the near-term future, where we're going to see a lot of these things happen. We're going to have AI doing specific tasks. The LLM might help with connective tissue, but that's what it's doing. It's just connective tissue on traditional solutions.
What was the art? I'm not a very good chess player, but I do on like games and yeah, against computer from easy intermediate level master. It's almost impossible to beat these like programs. And I was just curious like, how, I guess you just explain like, LLMs can or agents can tap into that type of like algorithm right on that existing program on chess software, use that database, and then continue on and just annihilate it.
Yeah, because how this I expect this to be set up by chess.com, because I'm sure chess.com at some point is going to do this because it's funny. So this is like an example. This is an actual chat on the right here as part of the paper, which is pretty funny. The whole point in conversational chess and is this idea of a universal interface, which I think is a really cool opportunity with LLM. And you don't have to you have to click the pieces, move it around, like you have to understand the interface. But here you can just talk. And so it's universal interface.
So these are on the AutoGen website, and again, they just serve the purpose of like hello world, like thinking. The pattern or the software pattern is you have a three-way conversation happening. And yeah, to your point, and the point Brian is making, and then that's where the agent stuff can come into play, right? Because like an LLM, as we've already talked about, is not trained to play chess, right? But you can call out to other models that might be a good example of where you could use an agent with multiple, LLMs and multiple models. But I want to save us from going too far down this because this is definitely not meant to be an example of like, hey, we think you should go build chess with OpenAI. This is just to show a software pattern on the AutoGen website.
Yeah.
Really new to the AI stuff. Is this anything?
So what AlphaGo is it's a specialized AI. So like AlphaGo is really good at beating Go. But if you ask it like who the first president of the United States is, you're not going to get very far. So when we talk about like this idea of an artificial general intelligence, and this is sort of like the boogeyman in the closet, is that it's sort of like an AI that can do everything. And the truth is that LLMs are not that. You cannot do everything. We can make it do more by giving it access to other AI, and LLMs will be what's really cool about LLMs act as like this connective tissue. So you could imagine having like 5 or 6 or 7 different specialized AI, and then the LLM communicates between that in order to create a system. Yeah, it composes them together, and so that's what the agent stuff is looking at. It's like this compositional system where the LLM acts as like the composition. But the LLM itself is stupid. The most useful emergent behavior is the fact that it can form these queries and it can sort of get everything to talk to each other. So that's sort of like the more useful use case.
Again, you already have this model that's trained, like trained to play Go, or like trained to do information on a radiology and for cancer, right? But that's only half the battle. Then what you need to do is you need to compose some human understandable language that describes that image, right? Because that's what we're trying to do is use the burden of the doctors, right? So we
burdened them for the last 20 years of technology, and now we're hoping we can finally unburden them a little bit with AI. So the idea is, and so to Brian's point, that shows again some of the interaction, right? And so the agent is handling that. Right? And here's actually really fascinating. Let's add another moving part to agent, right? Because this is really all that's here. This is something we have to figure out today. What I want to know is when somebody types a question in the chat, first of all, first thing, is it a clinical question or an operations question? Because if it's a clinical question, I'm going to go to a completely different large language model than I'm going to if it's an operations question. And then furthermore, if it's an operations question, depending on the type of operation, I may still go to a different model, and that might be dependent on cost. Because if we're just doing value type stuff, then why should I be paying $5 for ChatGPT when I can use an open source free model, for example? So you see, so we can add another step to the agent right away, real world, because I'm just looking at this today. Like, first of all, is it a critical question? If it's a critical question, all bets are off. Go this way to Medcom or pick your LLM critical network of the day, right? I think there's 1,000 people working on different stuff on and everybody's hoping to do it there. Certainly all the big companies are. Microsoft's working on them. Google's already announced Medcom. There's I don't know if that helps.
That's also that to be matters in the
Yeah.
message.
Yeah, because I have a question. So these decisions have to be large language model the right place for decisions to be made, or actually want to have something else which is
Well, they
trained very differently.
Well, you do. The answer is both, and more. Maybe you want all. And actually, what's really cool is when we get to the demo part, I'll show you, like, this is real world today. Like, there's even developers. So I'll show you how you can actually build this today. And but maybe you want to do all three. Maybe you want to go to critical, large language model that can be finely tuned specifically for critical use cases for one part of your task, right? And then you may want to go to another, maybe it's where you're doing another part of the task, composing a letter. Right?
Well, my question is, what's the correct technique to make those upfront decisions?
Well, you have to build it. That's where we're at right now. That's why I literally not joking. I was literally just thinking about this problem. Like, and I came across this model on Hugging Face. That's how I discovered it. So Hugging Face is sort of like GitHub for machine learning models and code, if you will. And so I was just curious if sort of like top-down notes on Hugging Face, like what models are being used the most, and then I limited it to healthcare. And one of the top 3 models was just that. All it is just a prediction on is this a clinical question or is it not, right? And so I thought, well, gosh, that's extremely valuable because that's one of the problems we have. Somebody's going into our chatbot, if they ask an operations question about their RVUs or FTPs or something, like we want to do a T-SQL query, we'll use a different agent, we'll go query PeopleSoft, get the chart data, and answer the question within the context of each other.
Still a norm, correct? Making these decisions.
Yeah, I have to do it in my code. That's why I was looking at my code. I'm going to have to say every time a new chat is entered into the window, I'm going to have to do a check. And what I have to find out is, okay, what's the performance hit? Like let's say I deploy that open source model. So first, can I deploy it to add? Second, let's assume I can get it up and running. Well, what's the latency like on that, right? Because that's just the start of my process. Like just determining if it's a critical question. Then if it is a critical question, then I've got to go establish it with Google Medcom or whatever.
What text string comes in.
Yeah.
All right. I don't think you're writing code that's actually looking at the text string directly and making that decision. You are in.
You're going to use an AI model.
You're going
to Hugging Face.
Okay, so the model of Hugging Face. You know how that was trained?
No, but it's a model that's supposed to detect if something's a clinical. I'm not recommending it. I'm not saying go download it today, build a system. I'm just telling you what's real world. What I'm doing.
I'm interested in what way they went. Which is
Yeah, but-
Otherwise, you would. Otherwise, sorry, to your point. Otherwise, you would have to read the prompt. What people are doing today is they're prefixing the prompt with like copper Paul or whatever, you know, and then you're like, okay, get this starts with this prefix, then go run this function or something. But we don't want to tag the
You
prompt.
don't want that. And
Yeah.
Pretty good decision.
Well, I-
You found one, but I'm interested in
One.
them. How they made that.
And the main point is built this. Like that's where there's so much opportunity right now. If you were to ask me, you know what I mean? That's why we can pause for Facebook on run it, you know, because I saw the the writing on the wall, if you will. So welcome to the world. That's where we are. In the last 4 months, have been nothing more than laying infrastructure. ChatGPT was just the beginning. It was like the internet. It was the first killer app to sort our appetite. And now that's why we're so thankful for Horizon here, because now this is the next phase. This is where you're going to see nonstop 12, 24, 36, 48 months and something about agents and auto agents and prompt flows and prompts and workflows.
Yeah, because I think the biggest thing to what you're saying, which I actually really like, is that someone's going to go train an AI for clinical to diagnose clinical things. And that's going to be trained, probably broadly speaking, on feeding it a ton of clinical information and like clinical results and having it like full extrapolation predictions based off of that. And just very similar to like the AlphaGo example, is that it's going to be really good at clinical, but it's going to be really hard to access. And the traditional way of accessing it is that you have to build a system around it. But what the LLM and like these agents and sort of the ecosystem is, it's all about sort of like what the LLM is just going to do is going to form the query and send to that model. And then when the model responds, it's going to like maybe frame it in a way that a user could access it or read it or understand it. So you can imagine like that being attached to like we give access to, I don't know if that's a good idea, give access to users or just like everyday people that have questions about like, oh, I'm feeling this, that. It's like a better version of like an MD. And then it'll go into like that clinical AI, do a prediction, send it back to the user. It'll be framed like, oh, this is what it is, but like be careful about like this, that's that. So, but you can sort of see this orchestration of a bunch of different systems working together, where the LLM's job is not even making decisions, it's about translating. So it's like translating human text into machine text, or translating from one machine system to a different machine system. So we still need to be very mindful about like how we organize this for both security reasons, because we want to make sure that we're not like creating vulnerabilities, because this opens a whole new door of exploitation. If someone can figure out how to get your LLM system to trigger the wrong thing at the wrong time, especially if it's doing things that will change state in the underlying system. A lot of the use cases you're seeing right now doesn't change state. When you're asking a question, like it's not changing the system. But we want to get to the point where you're able to be like, oh, transfer money for me. And now all of a sudden it's affecting people's accounts. That opens a whole new door of security issues. But this use case in particular, going to like what you're saying, is I think really interesting. Is not solving the problem they have. Again, it's how it works, but it shows this idea of deferring to a quote unquote expert. And the expert could be a human, it could be an LLM, or it could be a different AI model. So the idea of like how this problem works is that the student gives a problem, like a math problem, to the LLM, and then the LLM determines, can it solve it effectively. And if it decides it can't, it will defer to the expert to solve, like expert's advice, and the expert's advice will be wrapped into the response back to the student. And so the LLM doesn't have to ask the expert, but it has as an available thing, and that expert could be another human. So you could imagine this almost acts like a very weird human-to-human chat, where the human, that the expert doesn't actually have to care about framing the answer in like a way a person can understand. You could imagine the expert might be like a PhD in math. If the PhD in math tries to respond to like a high school student, that's going to end badly. But now all of a sudden the LLM is going to translate from the PhD level down to the math level, but like that information helps it answer it correctly. So I think this is like a very interesting use case, because you can see where this is going to go, where it could maybe defer to many different experts or different kinds of systems. Like expert could be many different things.
It could hear it. Like,
Yeah.
I love that you brought that up, because that's the one that intrigues me. I think it's like a workflow that we do today, but where you pause for approvals, like when this was goes on. And so I think that I can see some really valuable, use cases, right? Where getting to the point of AI safety and trustworthy, like having a human being able to, step in at a certain point in the flow, if you will.
I have, when you're talking about the LLM deciding that it's not good at answering this question, or do
Yeah, that
LLMs
one-
have that capability to
Well,
understand
it's-
that what they're doing is not good?
what I would say is it has the same level of capability as it being able to pick moves on a chessboard. And so, like, strictly speaking, if you had a system that was for, like, it kind of depends on, like, how important it is that the question gets right. If you're talking about, like, a tutoring use case and, like, the answer to get it wrong is an annoyed user, maybe that's not a big deal. But when you're talking healthcare, more likely or not, you're going to default to a different system, and the LM again is going to just translate to that system and ask this other system that's trained or set up or engineered to make that decision in a way that we like that its accuracy is high enough.
But that's different. In that case, the LLM is not going to answer. Wait,
So
LLM would come up with an answer to decide that it's not really sure about that. Go ask
Well,
somebody
first of
else.
all, Bill, and we can just be this, we about to show a demo.
Yeah, if you want to just jump in
where
and-
you can mitigate that type of stuff, because it is really important from the software architecture.
if you just want to jump into like the demo, that's pretty much all I had. So,
Sure. Okay, cool. So, you want to pass the projector?
yes. There you go. Make sure you share on the online thing.
So let me just share. So I'm going to fly through a bunch of stuff that I think you'll find interesting. And this is, now I'm going to tie it into what's today in the Microsoft world, if you will. And so the reason why this is important, Brian alluded this in the beginning, and I actually was supposed to do this as part of my intro, so I apologize. I'm going to do it now. But first, let me just point out a couple of things. What you're looking at right now is our new healthcare and HLS community on X. So this is not one that's managed by Microsoft. It's actually managed by the external community, but we have the support of Microsoft. So if you look at the people in the community, there's some program managers from Microsoft, et cetera. We try to do a meaningful post a day, and a lot of it lately has been on, last week was Ignite. So there were some really big announcements on AI last week, and a lot of those announcements were around prompt flow and agents, et cetera. And so that begins to explain, why this is important. And then to really continue to dive into, why and how. So I think, if you explore just some of these links here, like, so for example, last week, Microsoft introduced, I think, I heard literally something like, there's 100 different co-pilots now. One of the biggest one was the Microsoft 365 co-pilot. So that's up here. But the ones I wanted to look at are a little bit more technical, if you will. Like, so for example, the Azure AI Studio, this is something that is very relative to what we're talking about. It's essentially where we deploy models in Azure. So we can deploy multiple models and then use them. So all these links are up here. I don't want to spend too much time, but this one actually is really important. The semantic kernel, when it comes to this agent stuff, the message last week at Ignite was that if you want to work with agents and assistants, or basically the equivalent of, OpenAI calls them GPTs, I think. Do they call them GPTs or chat GPTs?
I think that's
GPTs. Yeah, GPTs. So basically, what it takes to make a GPT, all that stuff, basically that you can find that in semantic kernel and a couple of other tools that I'm going to share with you. And there was also an announcement made about matching up the API and the work in semantic kernel with OpenAI's work on, they just announced their new assistant API, right? And so that's why all of this is relevant. I just wanted to start there. Like, that's why we picked the topic today. It wasn't because it's like, oh, it's AI, it's such a hot topic, and if we talk about auto AI, we'll get some people in the, not at all. It's because this is so relevant right now. It was literally like the number one thing that was being discussed last week at the Ignite conference. And the really cool thing is Microsoft's actually released some really great tools last week too. So now we can literally see and use some of these tools and see what it looks like. And so that's what I wanted to do for the demo. The one I'm most excited about, well, let me start with this because there's a lot of questions around prompts and how smart are LLMs and all that. And the fact is, I don't want to get too much into the details about the complexities of that. But the important thing is that, there's really bright people working on finding ways to mitigate some of this, and there's already some really creative solutions that are surfacing. Like one of the things I've been most impressed with is this work. It's actually from the Microsoft engineer I think I was talking about earlier, the same one. And where he did the SQL query. Now his query, notice he was actually querying Cosmos. So I had to modify his code to query SQL Server. But the part that I really want you to pay attention to is this query prompt. So you see how specific he's being in the prompt before he hands it to the LLM? He said, write a Cosmos DB SQL query for a container with data about hotels. And then it has the following JSON schema. So he's even giving the LLM the JSON schema. I mean, you would have to have the temperature set at 90 for an LLM to, a decent LLM, I think, to mess this up. But anyway, here's the thing. And then the query needs to find the following information. If you're returning aggregate functions, be sure to return a value before calling these functions and output only the query and nothing else. That's the other key thing here that's making sure this prompt is saying, don't give me any other language or anything else, only the query. Now that's really important because what I'm going to do is I'm going to get that query from the user, right? So the user is going to do a prompt. And in the notebook, I think it's down here. So but by the way, let me just share this. So notice what's really cool now is that we can also have functions that are tied into these, that can be called as part of the talking to the large language models and also the through agents, right? We can work with functions. And so you see there's two functions here defined: query hotels, and then one to actually book the hotel. That's another great example of where you might use an agent, right? Because then like once somebody selects their hotel, then you might want to go through this complex process of actually booking the hotel for them. But in this example,
the thing I really like about this too, it goes back to like LLMs can't think, but what they're really good at is linguistic tasks. Is that this is fundamentally a linguistic task.
Exactly.
You're asking it to translate from one written form to another written form, and it has lots of examples of both of those forms. So all it's doing is like this complicated version of translating. So it's not really making decisions so much as it's translating from one to another.
Exactly. Yeah. And so by the way, he claims they've had very high success with this recently. We've just recently started testing it, so I can't talk about it too much in terms of, but I'm very excited. So far, it looks good. And so you see here, now we're setting an even more specific system message. So the system message, it turns out, is super important when it comes to when we're doing RAG and augmenting the data and all this like agent stuff that we've been talking about. And part of that is because you're setting the context, right? That's one big way that we set the context of the model. So that's that. And then we, if I scroll down here a little bit more, this is actual, the code that would make it all work, So basically what happens, it calls off, it connects to Azure OpenAI, and then it gets back it converts the SQL query through here, calling out to the function, and then calls and queries hotel. So that I was not prepared to show that. That's just some recent stuff that we've been working on. But the reason why I wanted to pull it up is to answer your concerns, which are, by the way, are super valid concerns, right? We have to deal with these things. But that's like, you can see from a software perspective, like where it's going is that, you need to get really granular. If I were to ask this saying, hey, write a book on clinical surgery, of course, it's going to start hallucinating after page 10 or something like that. But when I'm getting really specific like this, so far the results have been really good.
Yeah. The other thing too is I know that there's another paper that's really interesting that's called Gorilla API, which someone fine-tuned an LLM specifically for calling APIs, like in this kind of fashion. And what they did is that they had another LLM sort of like validate whether it's good. So it adds this redundancy. And if it was bad, they just recall it until it becomes good. And they found also the same thing. It's like a lot of success, especially because they had a repertoire of 1,000 APIs that could potentially be called, and then all the semantic details between all these APIs. And even with that much data it had to sort through, it was having a relatively good like success rate.
So we're at a point now where it's not always a person telling each agent if it's giving you a good response or not. We're at the point now where each agent has to be responsible for it knowing it's getting back a good response from.
Well, that's one method. Again, I think a lot of this, and this is where like a lot of this discussion gets difficult, is that very much depends on the consequence of it messing up. Mm-hmm. So, like, if the consequence of it messing up is that you have another system that's a traditional system that will catch it, then like you have a lot more leeway for having agents check agents. But if like the consequence is like something terrible is going to happen, you probably need you either need a human system that can ground it, and goes back to the question of grounding, is how are you grounding it? You either need a human to ground it, or you need a traditional system that you trust to ground it.
Okay.
This addresses the question of what's this going to do to programming jobs, and the answer is it's going to make a lot more.
Yeah, exactly.
Yeah.
Just like always. That's just silly.
My job.
And no, but just for the record, there were some of us in the room that never were, just for the record. I mean, that's just silly talk, right? And we were talking about this earlier. The fact of the matter is, without cutting into our topic, humans have been on an upward incline with technology for literally thousands of years. Certainly for the 7,000 years we have documented written history of, you know what I mean? And so if we were to zoom out, we're really just continuing that thing, right? And of course it's going to get crazy. Gosh, imagine the conversations they've had throughout the years. But let's not get sidetracked because it's real now. So anyway, so let's get very technical now and look at. So this is one of the things that I was most excited about at Ignite was this announcement. So first of all that the slides that Brian had, and he was talking about retrieval, augmented, RAG, and grounding your data, etc. Yeah, that's fine. I'll be able to keep things going for you, and I'll catch up with you.
And I'll make sure to post both like the slides, and then I'll also post a bunch of references to like papers I thought were interesting on this topic, because there's quite a few of them that are interesting that aren't too technical to have to go through. So
this is a project that I'll demo in just a minute, but it actually comes from, this is the cool part. So was announced at Ignite. It's called Chat with Your Data Solution Accelerator. So this is basically, you've probably seen on ChatGPT how you can connect to a spreadsheet and then you can start questioning the spreadsheet. That's great and works really great for consumer applications. But the reality is in the corporate world, especially in healthcare and healthcare organizations, we want to be able to do this in the context of our own data, right? And do it in a secure way. So that's essentially what this GitHub repo is. And this is a GitHub repo, so I just have it open in VS Code. So I would highly recommend you check it out. And now what's interesting is one of the engineers, I'm pretty sure he worked on this because he has a private repo called, it's basically the same thing, but it says intro, is the last word. And by the way, I will have links as well. So I'll share it with you. And what's interesting is that's where I got the Cosmos DB example. Okay. So actually, I lost my train of thought. This that we're looking at is actually, it's called the Prompt Flow Extension for Visual Studio Code. So this was announced at Ignite, and you install this just like any other extension. So I'm in Visual Studio Code here, and if I go into my installed extensions here, you can see I've got a bunch of Jupyter stuff, but down here I've got this prompt flow extension for VS Code. And so what this does is it basically gives you the tools that you need to be able to do this in Microsoft land, working in VS Code. And so what's fascinating is it makes it fairly simple. There's some great examples, and I can see where there's a lot of room to run with this over the next couple of years. I pulled up just a really simple hello. This is basically the hello world example. Just so you know, I am running it in, I needed it's Python code. So you do need a Python environment. I struggled to get it to work with Python 3.12. So I just installed the Python, is it Conda? I hope I'm pronouncing it correctly. And that is essentially what's running here. And then what you do is you just say, well, create a new prompt. So see here, there's this new thing that it gives you. And what's super cool is the first thing you have to do is you have to set up a connection, and it'll even help you with the connection. So see, I just did this today, just playing around. It didn't take that long, but I actually have GPT-4 deployed. So this is on Azure. These are private instances of OpenAI. And so a private instance of GPT-4 and a private instance of GPT 3.5. And then what's really cool is if you open up the YAML file for the flow, then you can see how this thing is put together. Now all this comes together, what Brian was talking about in the slides, right? See how the agent, and by the way, this might be tied to an agent, right? This is more about prompt flow. This isn't building an agent itself, but this is the same exact type of stuff that would be included in an agent, if you will, literally the code. So we have our inputs, right? So the input for this one is, well, what's the topic you want me to create a joke about, right? And then the output, of course, is going to be the joke itself. Now, notice, though, in the flow of the prompt, there's only two things that are being run, joke and echo. So joke, if we look at joke, I'll see you later. Thank you so much, Brian. If we look at joke, you can see joke is, first of all, it's a connection. So this is a connection. I literally, no, I'm sorry. It's not, it wasn't. It was added, and then you had to select the connection to the large language model. So this one is using the 3.5 model. And then you can see there's some settings. You can change the temperature, etc. And then finally echo. So joke goes and gets the joke, and echo is only responsible for just printing it. And so you can see in this echo stage, if I click on it, what it's actually doing is it's running echo pi. And if I look at echo pi, you see echo pi is doing nothing more than just returning that input stream, the joke, right? So again, going back to this, we have, now this one I added just to test. So for the demo purposes, so I got these two to work, and then I was like, okay, I'm going to add a third prompt, right? And the third prompt is configured here. And why does this look a little bit different than it did earlier? Anyway, this is the definition for the, oh yeah, right here it is, sorry. And then I just asked it to send the topic back to the network, because I'm just testing. I just wanted to show that I could do a third prompt, right? But now what's interesting is, notice, because we were talking about this in the PowerPoint slide, notice I have multiple connections to multiple LLMs set up here. So I could very easily, you see how I could do this now? I could just add another step in my flow, but this time, instead of connecting to the 3.5 one, I'll connect to the 4 one, and then set up the parameters and pass it through. So it's cool. So then the end result is you can actually go in and you can run and look at this in a local app. So you can run it either in a container to test it, or you can run it as a local app. And so you can see I just chose to run it as a local app. And so just as you think, you come up with a topic, and then it should work as expected and return a joke on that topic. So
What
yeah.
did your extra LLM do at the end? Your prompt one?
Nothing.
Oh, okay.
All I did was I created a prompt that sent the input to the LLM, because all I was doing is just testing, and that was as far as I got this afternoon. Like I literally did all this in a few hours this afternoon. Yeah, it was something that's been top of mind. I saw the announcement at Ignite, and we're doing a ton of stuff right now at the development level, the programming level, in short, in connecting systems and not necessarily clinical systems right now, more on the operations side of healthcare, if you will. And so here's a really good example of some real world stuff that we're looking at doing with this. One of our very first use cases is we have a platform that essentially manages RVUs and clinical time for providers across hospital systems, if you will. And so, one of the common requests that come in through what's called provider services is, what are my RVUs, or essentially, what am I going to get paid this month, right? And so for us, what we're excited about doing now is basically we're getting to a point where we can accomplish that through a Copilot interface. So instead of having to go to a report, a dashboard, et cetera, you just go ahead and say, what was Dr. X's clinical time for December or whatever. But now the minute and then I can do that part, right? I already showed you the code today, that we can convert it to a SQL statement, connect to a SQL server, get that data back from ultimately it's coming from PeopleSoft. We bring it over to SQL and then we so we can, we can do that today. But then the next thing you want to do is, then the next request, how it is when you start developing product, right? The next thing is but now we want links. We want links to the forms they signed, right? That type of thing. So it looks like our approach will be, we'll make this thing as an agent that handles these requests, right? And so even if it's a simple query that can be answered with a pretty straightforward query to, let's say, PeopleSoft data, we ground it in PeopleSoft data and send back the response. We still want to be able to. We want to be able to do that in a safe way, if you will, repeatable way as well.
Let me ask though.
For
this type of thing, I would assume there's a set of standard things which they're constantly looking for. So the traditional way you would build.
Yeah.
You said on a dashboard, and you would just build those.
Yeah.
Is there enough non-standard stuff that comes around to make this fruitful?
I think there is. Yeah. And I think, and for us, this is just a low-hanging first use case on the operations side, really just using the chat functionality and some lightweight chatting of data. But no, I believe there's a very large opportunity, even just on the analytics side in healthcare, for how users are asking for data. And actually, in our next step, what I would like to do is I would like to have it. So we actually, these providers we call it an attestation form once a month that shows them what we think they're doing around the hospital. And it usually takes like 30 seconds. We wrote it in .NET a number of years ago. It's worked like a charm forever. But what I would like to do is get to a point where they have multiple options where they can do that form if they want, but they can also just go to the same Copilot and go ahead and complete the form there, right? So show me what you think I did. Yes, I did. Digitally sign it, and it goes into the system. And so our goal is to effectively replace as much of our user experience as we can with a Copilot experience. And then underneath that Copilot experience will be agents and the prompt flows, which for me, there's a lot of gray area there, because the prompt flows stuff is a lot of what helps make agents very useful, if you will. So, at least from the way I'm seeing it so far in the architecture. And so with that, that'll end the demo part, but I hope it helps, because I think my main purpose of showing this demo is I wanted to take the next step and show you that this is very real now, that this isn't stuff that just people are talking about. And here's another way to think about it. I mean, Microsoft openly admits now in their annual letter, and it's clear just by watching any news or thing they say, is that they have spent the last 12 months pivoting to be an AI company. They've literally have changed the footprint of their data centers to handle the chips that are required, which meant they had to change the server racks, how they're cooled. I was actually amazed to hear at Ignite, like just how much they've been, adjusting over the last year, starting with the data center. And then of course, across all product teams, integrating Copilot and getting behind this idea of agents, and then giving developers all the tools, to go ahead and start using agents. And so again, I would just end in saying that I would submit to you that the last year has really been about laying the infrastructure, and that will continue to happen. If we were to think about it in internet terms, like the first steps, you had to put down your DNS servers, right? You had some universities that started talking to each other, and then you had the first killer app, which was email, right? And then it was like overnight, everybody knew what the internet was because you could press send and send an email. That was ChatGPT for generative AI, essentially.
Except that took 20 years.
Yeah. And so, imagine us in this, if I were to loosely use the internet, and I'm not trying to compare it to AI or anything. It just makes sense from a comparison perspective. We're at that page. We're at the very first, now, why do I need a web page? Show me why I need a web page, right? I sort of feel like that's where we are with AI in companies right now. And some people are just starting to see, if I have a web page, maybe, we're there, right? And so the other thing to remember is that when we first started, again, not comparing it to the internet, it's just useful for making these points. But when when email first came out, if I told you the internet was going to change the world, you might have sort of agreed with me and say, yeah, this is super cool because now you're right. I can communicate with anybody. I just have to press a button, right? But you had no idea, right? Now you fast forward 30 years later. Now, if I were to say to you, hey, the internet is going to change the world, right? Now we could have a very meaningful conversation on how over the past 60 years, ever since the DARPA DNS servers to where we are today with AI running in the cloud and mobile devices, that's a much easier piece of information to accept, if you will, right? So I would just encourage you that from my perspective, that I don't suspect this will be any different. It's not going to happen next month. You're not going to miss out on anything. It's not going to happen in the next 6 months. It already started happening, and it's going to continue to happen. But now is a really good time, if you haven't already started to get involved, to start paying attention to vector databases, semantic searches, the stuff that I shared with you. And one final note, the exciting thing is, again, just because this is a technical meeting, this is all very good for developers. Like this idea that, the AI will write our code. Well, first of all, I hope so, because we have a lot to write. And quite frankly, we're not great at it. You know what I mean? But it just opens up the door. Like there's just, and we don't even know what that's going to look like yet. Just like we didn't with the internet, how it will, what the impact it will have. But it will, but that, that's okay. So that's it. Yeah. Thanks. Thank you.
We were saying earlier that when developers at Microsoft are now given approval to use agents, do you mean for personal usage for productivity or to develop solutions with, or both?
Yeah. And I didn't mean to imply a permissions thing, because I don't necessarily know what that looks like. But I think what I was trying to say, maybe it got misunderstood, is that they've given I see where I got confused. I meant the developer community. So Microsoft, the company, has given folks like me and the people in this room, the developer community, they have given us tools to take this forward.
Got it. I see what you're saying.
Yeah.
Okay.
Yeah.
Yeah. Wow.
So do you have the repo for the system?
Yeah, I do. I planned on, I have the repo from the meeting we did 2 months ago where I showed how to build a Copilot. And my plans are to add these links to that one and then make it available to people. But please feel free, if you want to get it sooner, if you have any questions, you can just send me an email.
Sure.
I'm tswider@realactivity.com. Pretty easy to find online.
I got another question too.
Yeah.
In terms of, so what I'm kind of bringing away from this too is that it seems like a lot of the value here is being able to compose different agents together, and that's really what's going to give the best general AI. Is a big limitation right now just the sheer number of quality agents for different things there are. For example, we're saying earlier that there's a thing that makes a query, comes back, composes it. Let's say today we don't have a good thing that's good at composing.
Yeah.
Is that a limitation that we just don't have a good we
No.
have a good model for everything that we need to do to create general AI? Is that kind of?
No, as a matter of fact, I don't really think there are any limitations right now. I do think that ChatGPT in this last year was just about laying infrastructure, and it was the first killer app.
Mm-hmm.
We are just now starting to hear whispers of the second big thing. And I personally believe, but this is just speculation now, that the the stuff I'm about to talk to is really what's been behind this push for legislation and whatnot. That you know, sure, you can talk about things like misinformation and hallucinations, and that's very serious, and AI safety is very serious. But what we're starting to hear is, and again, there's not a lot known about this. It's literally just started surfacing the last couple of days in various news groups and whatnot. But there's something that's been dubbed Q-Star that, and you may have even heard about this. It was, some people say it was maybe the reason why there was a Sam Altman, strife at OpenAI. I follow George Hortz, who I think is one of the best programmers in the world right now. And what I love about him, he's an entrepreneur and runs his company, but he'll also, he literally just went online and coded for 2 hours, through live stream, and did AI. And what he did that was so cool is he deployed a Mistral, it's called Mistral 7 billion parameter network. Basically, it's an open source one that you can install on a developer machine. And he installed it. And then he started using some of the same techniques that we've heard from OpenAI about this Q-Star stuff. And literally, as I was watching him before his eyes, he was so basically what this is, so imagine, so you're working with these agents and you're working with prompts, but you introduce a reward function. And the reward function encourages it to do better and better and better until it's perfect. And so that can get really, really, really interesting, right? Because now, so when Brian was going through the slides and he was talking about that world, it was okay, there's some, maybe something, and that actually goes to your point too about how do you know something is right? Well, and again, this is all tech speculation at a user group right now. We're just talking over a beer right now, okay? But, so my point is that gets really interesting, right? Because now you can say, okay, and I don't know all the details yet, but essentially go do this task, and here's a reward function, keep checking back in, and that keeps making it work until it, whatever ends up being perfect or complete.
Yeah, I see.
So that can open up some really, really interesting scenarios. Will it get us closer to? I don't even get into the debate about AGI and ending the world in the dangers. The reality is that of course it's dangerous. Computer code is dangerous. The minute we started writing code on an Apple computer, it was dangerous. Trust me on this. You know how much money has been lost through crypto mistakes or hacked this, hacked that, right? Now, of course it's dangerous. And of course you need to debug it and worry about garbage in, garbage out. What surprises me is programmers that have been doing this for 20, 30 years. Some of the smartest people I know. For some reason, they start, the AI topic comes off and it's they take their head off for a minute or something, So anyway, but that's my perspective, and everybody has one, right? But I'd like to think mine's grounded just a little bit in reality, just because we've been working with this so close for so many years. So, but that said, I do expect that there will be a whole new wave of debate. I suspect there will be a whole new wave of legislation. I suspect it will really fire people up, and I suspect they will, and the other side will go, and but the reality is, if we're in healthcare, I view myself as being mission-based. I'm on a mission to save babies and improve qualities of outcomes in health. And sometimes I do this by showing up to a meeting like this at night and hoping that I'm going to inspire somebody with some code or get them into the industry. Sometimes I do that by designing mission critical systems that can be used for clinical and operations purposes, right? Sometimes I do that with Microsoft software, right? But there are other vendors. There are other platforms, et cetera, right? There are other AIs, there are other large language models. And when it comes specifically to AI, because I view us as being mission-based, we believe AI is a great way to save babies right now and improve the quality of life. Now, does that mean that we're going to go out right away and start, triaging babies with AI? Of course not. But should we start the mission right away? I believe so. I believe so. And so I don't know if that helps as well, but I'll just close with that. So, Thanks.
Yeah, thanks, Paul.
Oh, yeah, you're welcome. Come back next month.
Yeah.
We'll do it again. Actually, in December, we're taking a break for the Christmas break because the third week is so close to December. But then in January, Bob Derman from Microsoft is gonna do a presentation on some of the newer stuff they've been working on in Teams development and healthcare, et cetera.
Great.
Yeah, he's a great person to listen to.
Do you think you have to be like a machine learning engineer to get started with this kind of stuff until like
No.
get involved? No?
No,
Isn't it